So hello everyone, good morning. Myself Ranjan, working as a PCB design engineer at Innova Technologies since 4 to 5 years. And today this workshop which we are conducting is to understand what is PCB and basic design fundamentals to design a PCB and how does a PCB work and how the PCB is fabricated. So generally PCB means PCB abbreviation stands for printed circuit board. As the abbreviation says, PCB says the circuit which we have built will go through as a tracks with electrically conductive and printed, or it is also printed, or it can be say as etched on a bare copper board. That is called as a PCB. And PCB is one which supports mechanically to hold all your components and electrically connected using conductive traces, pads, and other wires and other things. So PCBs, it can be single-sided or double-sided or multi-layer, which you will see in the next process. As you can see in this image, this is a bare copper board, which is nothing but a copper, just a copper. And then after copper, it is that sample, it is ink deposition, that ink will be deposited as per your circuit diagram. And then this board will be etched through some sulfuric acid. And then after removing all the unwanted copper, the PCB board will be made. This we will be studying in detail in the next processes. So this is the example for two-layer PCB. Also, one-layer PCB will also be manufactured, but nowadays everyone will go for a multi-layer PCBs only. So as this is a two-layer PCB, which it will consist of top layer and bottom layer, and middle. In middle of these two layers, there will be a core. So core, what is the core? Is a core is a thick, more rigid layer of a glass fiber or copper, which is sandwiched between two layers, two conductive layers. It acts as an insulator between the two layers. So no shorting should be there between the two layers. So as like that, coming for the four-layer PCB, here we will have four electrical layers named as top layer, ground, power, and bottom layer. So this ground layer is usually particularly used for the ground connections, like analog ground. Different types of grounds are there: analog ground, power ground, digital grounds, earth ground, RC ground, like this. And power, in power, according to our circuit diagram, which all the power we have in this in the circuit, we will going to etch those powers in this layer. And top layer, in the top layer, usually we will place most of the components on the top layer, and bottom layer we usually use discrete component. Discrete components means example resistors, capacitors, inductors, diodes. These are all called the discrete components. So this layer goes on increasing as the density and your circuit implementation, as per your circuit implementation. So this is for an example of two-layer and four-layer PCB design. So the key concepts of PCB designing is first thing is we have to create a circuit, that is called a schematic design. Then we have to convert that circuit into a layout using PCB layout designing softwares, and then the prototype will come after the PCB is manufactured. So this is the example of schematic and PCB design. The left side which you are seeing is a schematic. First, the schematic is drawn by hand or something as per our idea. Then we will create this, that circuit into convert that circuit into a schematic using some softwares called. We have so many softwares, free softwares also. Example like Eagle, Express PCB, KiCad, like that. And we have also paid softwares like Cadence, Altium, Pads, Mentor Graphics, like that. So first thing we have to do is a schematic creation like this. With all the rules we have to do, you will learn when if you go through the tool, then you will learn all these things. So first we have to create a schematic according to our circuit. Then the schematic will be imported as a netlist to the PCB designing. Then according to your consideration, design circuit consideration, we have to place the components and start doing the routing. Routing means routing is nothing but we have to connect the traces. Traces means electrically the two components should be connected through these traces along with the pads and wires, which you will learn in next slides. So for an example, left side which you are seeing is a PCB design. So this PCB design after manufactured and assembled, it will become like this prototype which you are seeing in the right side of the image. So left side is the computer aided design which will be converted as a prototype after the PCB manufactured. So these are the key elements of the PCB which you are seeing. So the pads is the where the components pads is the exposed region of a metal on the PCB board, where PCB board that connects the component lead and which where the components is to be soldered on the board, which is called as pads. And these traces are it passes the electricity where the footprint is placed. We have to connect the different circuits using these traces. This is nothing but copper tracks that connects all these pads and make a connection which carry electrically conducted. So these tracks, if you want to connect these tracks from one layer to another layer below layer, then here comes the picture of wires. So these wires are the small holes which will through the board that link from top to bottom. This is called a through hole wire, which is drilled from top to bottom. And in wires, you have three types of wires, like through hole plated wires and through hole non-plated wires. Plated wires means it is a conductive material which is around the holes. Non-plated means there will be no any conductivity, only the hole will be there. That is, for example, for mechanical support of the PCB, we use that non-plated wire. And another wire is blind wire, which you are seeing in the second number here. So this is it will start from top or bottom, but it will end in your inner layers. It will not come outside of the outer layer. It will start in one outer layer and end in another internal layer. This is called a blind wire. And here comes the third wire. This is very cost effective, and this wire is called as buried wire, which will be used only in the internal layers, where the design is very complex and all. There we will use this buried wires. So these are the key elements of PCB: the pads, traces, and wires. So pads is used to solder the PC components, and traces are used to connect these pads within electrically conducted, and wires are used to connect these traces between internal layers. So these are the PCB design procedure usually globally we will follow. First, we have to specify the design which we are going to build the prototype. So after the design is implemented from our side, then we will create a circuit diagram using bare hands or a written document like that. Then the circuit diagram written document is converted as a schematic design using various softwares. Then after creating this schematic design, we have to select the components on which based on our requirement. So if you're building an automobile based device, then you have to select the components according to that automobile grade. Or if you are building a component which is used as a medical devices, then you have to select according to medical standards. Like that, you have to select these components. And after selecting the components, we have to check the components dimensions and body. For example, see, this is a nail header. Header means it is a through-hole header. So according to this in data sheet only, they will provide all this. This is called PCB land pattern. They will provide this body dimensions and holes dimensions. Everything they will provide. So according to this holes which they have provided, we have to create the footprint using our software. Example like Allegro, Altium. We have to create this holes and body shape according to this data sheet, and this will be treated as a pads in the PCB where the components will accommodate. Then we have to export this schematic to the layout design. The exporting option from the schematic is called netlist, and it will be imported to the layout design. Then after importing to the layout, we have to place all the components according to the customer requirement or according to your implementation. Then after placing all the components, then we have to connect all the components according to your schematic diagram. So it will be integrated from schematic to the PCB after we import that netlist to the layout design. So according to that circuit, you have to route all the connections and you have to connect through with the help of traces and wires. Then after routing everything, we have to generally check up the design rules which we have set. For example, for a USB, it is a 90 ohms impedances. So we have to match that impedances. According to that impedances, we will be setting a set of rules. So those rules are matched or not, we have to check at the final release of the layout design. So these after checking upon of these design rules, then we will generate a Gerber files. Gerber files along with the drill files. These Gerber files is nothing but the output of your layout designing, which you will get, you will provide these Gerber files to the fabrication process to build whatever you have designed in the layout. So after giving these Gerber files and drill files, the PCB manufacturer will take that computer aided designs, the output of the layout designing as a Gerber file, and take that as an input for the next PCB fabrication process. So this is the overall procedure to start from a circuit designing to up to the output of the layout design. So coming to the fabrication, these are the basic steps which we will follow in fabricating a PCB designing. Imaging process means, imaging process is central to creating a PCB layout and defines the circuit traces. And panelization means one by one we will get through in the next slides. So this is the imaging. The PCB fabricator first he will get the in the earlier slides I told you Gerber files. So that Gerber files they will take as an input, and this will be readed as a computer aided manufacturing database into their system to create this etching process. This is called imaging. They will use this software such as Siemens, Autodesk, and CAD. Other softwares they will use to create this imaging. So after the images are created, they will do a panelization. This panelization is nothing but it's a procedure where this all the multiple number of PCBs are grouped so in order to provide a mass production, they'll group all this PCB and do a panelization to reduce the time. Because if you want to do a single PCB at a time, then it will take too much time to fabricate a PCB. So they will group all the PCBs in a single panel, and they will onto a larger board panel, and they will get started this manufacturing process. So after the paneling is done, the depaneling is nothing but after the panelizing is done. So for example, in this image, 8 PCBs are panelized in a single larger board. So depanelization means after panelization is done, the circuit boards will be break out after from that large board and make it as a single boards. And then this depaneling, after depaneling, the copper patterning will be etched according to our circuit designing which we have built. So this copper patterning is it will etch the copper and then removes unwanted copper which is no use. So after this depaneling, etching process will come. So there are two types of etching processes, which is chemical etch and laser etch. Chemical etch was mostly used in very it was a old method, and laser etch is the common method which is used all over the world. Chemical etch is used for very small boards and which is very cost is very less compared to laser etch. Laser etch has cost. It has more cost and complexities there. In chemical etching, usually it is done with the ammonium persulfate or ferric chloride. For while doing the chemical etch for plated through holes, the additional steps of electrolysis deposition, the holes are drilled. Then this ammonium persulfate is it is etched on this plated through holes. Then the copper is electroplated to build the thickness according to your customer requirement, we will be electroplated those according to the thickness, means 1 ounce, 2 ounce, like that they will be manufactured. Then comes this laser etch. Laser etch is a process which will be created using the standards like chemical process, like plasma etch and all. In addition to this laser etch, the process it will eliminate the imaging. Compared to chemical etch, it is very the error will be minimal, and this eliminates imaging, which transfer the layer image directly to the material without any errors. So this laser etch is only most probably suitable for all the PCBs etching process. So after the etching is done, then we go for drilling for plated holes. And if you have any components with through hole type components, then these drill holes will be it will drill the holes according to your design. Typically, this drill holes with smaller drill bits made of this carbide called tungsten. From smaller to larger, there will be having multiple drill bits, which will be performed manually. Also, it will be performed on automatical drilling machines also available. So after this drilling is done, so then the assembly process will be taken. Left side, which you are seeing, is a manual assembly process, and right side, which you are seeing, is automatic assembly process, which is done through variable multiple components. So left side, which you are seeing, is manual soldering, which we will do to accommodate that placement. Automatic is done by machines. Machine will be loaded with X and Y coordinations. The placement which we are done in the board, we will get the output of that placement. So that placement output will be treated as a X and Y coordinates. These coordinates will act as an placement for this automated machines. So after assembling of all the components, then we will go for electrical test. Electrical test is nothing but to check the interconnectivity of the PCB, whether the tracks are properly etched or it is broken. There will be there should not be any open circuits, so that the track is connected from end to end, and it should not short with any other nets. So we usually will do this electrical test. This will also be done automatically and manually. Manually means using our CRO and multimeter. We will use this probe testing. Automatic means the system machine only will test the full overall board with the netlist which we will be providing for the system. So after this electrical test, the board, if it is all the power is up, then board bring up is done and the board is ready for the use. Then the prototype will be released. So these are some free PCB design programs which you can use, which you can download freely. Example like Eagle, KiCad, Express PCB, and Design Park PCB. So you can learn through many videos will be available in internet for this free PCB design programs. So you can use this one. So these are all some of the examples of designs done in our technologies. This is a loop back card which consists of 32 numbers of BGS and with lots of a very complex board with 15,000 pins and signals, 16,000 signals. The main constraints was very angle routing with minimum spacing of 3 mils. So this was a very critical card. It is called as a network card usually. It will be installed inside the laptop or motherboards. And these are all, this is a computer application card. This is also usually comes under motherboard pattern. So this is this also consists of 24 layers. This is a layout designing image which we are posted here. And this is a card which connects the laptop, our system with hard disk. Hard disk means this is not hard disk, SSD, solid state drive, and it consists of M.2 connectors, latest technology connectors, and PCI connectors. And this is the board which we have done for aerospace companies. So this is analog video switching board which uses multiple video formats to generate the video outputs, designed for avionics on board computer for compact aircraft. It is used in the Tejas networks, Tejas aircraft. And this is one system on SOC circuited, which is used in defense system, which will be used as a, it will be used in rugged PCs. It consists of HDMI, PCI, and 5 signals with the DDR3 memory and serial data interface. It also consists of static DRAM. So this is a 12-layer board with very complex and with very minimal spacing of 4 mils, and high performance digital media. So this is one of our challenge board which we are done in Innova Technologies. This is a medical equipment. You all heard about pacemaker, which will be inserted inside our heart. So this will be a very tiny board, which you will see, very miniature medical device. For continuous monitoring of ECG and other medical things, this board is used. This is a US based project and we have done in India. So I will be presenting one video which you all can see.
Hello, sir. I'm audible?
Yes. Hello.
Okay, sir. You finished, right?
Yeah, it is finished.
Okay, sir. Dear students, if you have any questions, then you can ask.
Hope everyone understood what the workshop is based on.
All right, sir. Dear students, as this is overview of PCB designing workshop.
Yeah, this is just a overview of PCB designing.
Yes, yes. This is just a overview about PCB designing. In future, we'll be going in depth about each and every process, like how schematic is done, how fabrication is done, how imaging is done, what actually is panelization, what is depanelization, copper patterning, what is actually etching process, like sir explained, like chemical etching, laser etching, drilling. Okay, so each and every process will be in depth taught if you people are interested. So please let me know who all are interested in PCB designing. So once I get a list, we will talk to Ranjan sir and we'll surely arrange one more session on the, not one more, we'll be arranging many sessions related to PCB designing. The only thing is you people should be interested in learning the things. So as the time is running out, thank you Ranjan sir for sparing your time and addressing about PCB designing.
Yeah, thank you, sir. Thank you for giving this opportunity to teach your students.
Okay, sir.